All right, so Venus, sometimes called Earth's twin. And if you go back to that chart or you remember the chart, it was the closest in size, it was the closest in mass, it was the most similar density, and the most similar gravitation. It's also the closest planet to us, only 27 million miles away. So just a short little trip there. And again, once you find a new planet, you want to look at its rotation. Well, Venus has a lot of clouds. If you remember, the atmospheric pressure was 90 times that of Earth's. So there's a lot of air and stuff on Venus. So it was hard to determine because you couldn't look at anything on the land surface and figure out what it was. But they ended up figuring it out. It was 243 days for it to rotate. It's also going backwards, retrograde, clockwise. No, its orbit is counterclockwise, just like the rest of us, but it spins clockwise. Strange. The only explanation they can come up with is it had to have been a collision with another planet that knocked it over. Okay. Now, Venus is hot. 600 degrees Kelvin with an average of 730 degrees Kelvin. Hot. Its atmosphere is very, very thick, very dense, as I said before, 90 times that of Earth's sea level. And you can pretty much consider Tampa at Earth's sea level. Right, so 90 times the amount of pressure you have on you now. Which might not, if you're like, well, I don't really have any pressure on me. I mean, I can't feel it. I move around just fine. But 90 times is a lot. We actually do have a good amount of pressure on us. We just don't know it because we're so used to it. 90 times would be like taking a car and putting it on you. And not just one car. A whole bunch of cars on top of you at the exact time. But what is this atmosphere made out of? Carbon dioxide and nitrogen. Carbon dioxide, almost 97% carbon dioxide. The rest of it is nitrogen. And the clouds are made out of sulfuric acid. Our clouds are made out of water. Have you ever smelt sulfur? It smells lovely. Think of rotten eggs. Now the clouds are made out of that. So when it rains, it's raining acid that smells like rotten eggs. Pretty neat. Alright, so we couldn't really see anything on Venus through visible light because there's got too many clouds. Can't see through it. So we used UV and infrared. And that looks fairly pretty. Again, false coloring, right? So it looks blue and white when really it's not. But you can see the white actually represent bands of clouds. Clouds made out of sulfuric acid. So think more yellow. Maybe red. Right? And these clouds are moving very fast. 400 kilometers an hour. Faster than NASCAR speeds. And so they think that underneath these clouds is a haze. And then underneath that haze, it's actually clear. So if you were to stand on Venus, you would have a nice clear air-ish atmosphere before you would hit the cloud level, before you would hit the haze level. And then you would have haze, and then you would have clouds. It's kind of like LA, right? You're standing there and you don't really see anything. But then if you go up just a little bit, you can see just the haze or the smog. And then if you go up further, you can see the clouds. Kind of the same thing, except instead of made out of water, we're made out of sulfuric acid. Now, you can see the picture kind of focuses on the South Pole. The South Pole, they've actually discovered a vortex. So a spinning cloud. Does that sound familiar to anyone that lives in Tampa? All right, so they think Venus actually started off probably very similar to Earth. However, it retained more of the greenhouse gases. Now, Venus is closer to the sun, and the sun got warmer as it aged, and so Venus got warmer. And then, because it retained more greenhouse gases, they think it got so warm that all of the oceans evaporated. Now, greenhouse gases are carbon dioxide and water. Okay. So they think all of the oceans evaporated. And so both carbon dioxide and water were released into the atmosphere, and it was basically just a runaway greenhouse effect. Sunlight would come in, it would be trapped, Venus would heat up. Sunlight would come in, it would be trapped, Venus would heat up. Sunlight would come in, be trapped, Venus would heat up. You get the idea. Now, a lot of people try and scare you that, oh, this is what's going to happen to Earth. Did you see the percentages there of carbon dioxide? Almost 97% carbon dioxide in Venus. We don't even have 0.5% here on Earth. So we've got a long way to go if that's what they're trying to tell us. All right, we've already talked about this, but it's a greenhouse effect. This is how it works. Sunlight enters the atmosphere. It warms the ground. The ground gives off a different type of light, right, infrared. And the infrared gets trapped by carbon dioxide and water vapor. So if you have too much carbon dioxide and water vapor, then you get trapped, and so that's why Venus, they think, is so hot. So with Venus's thick atmosphere and the fact that 97% of it is carbon dioxide, it's actually trapping 99% of the radiation that's trying to escape. That's a lot, which is why the surface temperature is 730 degrees Kelvin. It's a little bit warm there.
This is Venus, a planet completely shrouded with clouds. Winds rip around the upper atmosphere at over 300 miles per hour.
About 35 miles above the surface, the winds are whipping around in a ferocious pattern that basically carries the cloud features around the entire planet every 4 days.
Venus is closer to the sun than Earth, and it's heat from the sun that drives the wind.
The circulation pattern of Venus's clouds is actually quite simple. There's a warm side of Venus and a cold side. And as air warms up and rises on the day side of Venus, it spreads around to the night side. So there's this continuous current. It's actually quite a lot simpler than the atmospheric circulation on Earth.
Venus's winds circulate faster than the fastest hurricane on Earth. But they look very similar. The Venus Express probe captured these remarkable images of the planet's south pole.
One of the great mysteries of Venus, which actually had jaws dropping in the halls of many astronomy departments, is the fact that we have hurricanes at the poles of Venus, especially in the southern hemisphere, that have two eyes. Not one eye, but two eyes. Now, we've never seen this before on such a planetary scale.
Venus's double-eyed vortex is 1,800 miles wide. Two hurricanes whirl around each other.
If you could descend into the vortex of Venus, something I would love to do, at least with a remote machine, I think you would see some kind of a fantastic wall of cloud and this sort of twisting form spinning around you at ferocious speeds. It would be quite a sight.
It's a mystery how deep this raging, spinning vortex goes. But maybe this megastorm I descends to the planet's surface. Down here, permanent twilight bathes a volcanic landscape, and the atmosphere's colossal weight creates immense pressure.
And the atmospheric pressure on Venus is about 100 times that of the Earth. Think of taking a car, squeezing it down to about a square inch and putting it on every square inch of your skin. You'd be flattened within a fraction of a second because of all that pressure.
Venus's dense atmosphere creates one of the strangest megastorms imaginable. 4 miles per hour winds with the force of a hurricane.
The winds on the surface of Venus are actually very slow because Venus has a very slow rotation rate. It takes Venus about 8 months to turn once around with respect to the sun.
The crushing atmospheric pressure rams gas molecules together so tightly that they feel more like a liquid. A gentle 4-mile-an-hour breeze packs a brutal punch. It's like a hurricane in slow motion.
Winds on Venus are totally unlike anything we see on the planet Earth. You would almost feel like a molasses effect. It'd be quite difficult to simply walk and run right through the wind.
Venus's surface is so hostile that life is impossible here. But the upper atmosphere's faster winds hold an extraordinary possibility.
Well, I harbor this, I don't know if I would call it a hypothesis or a scientific fantasy, but I do think it's plausible that there could be some kind of life living in the clouds of Venus. There are certainly energy sources, there's sunlight, and there are certainly nutrients. There's carbon, there's hydrogen, there's oxygen. All the stuff we think of that you need to make life exists in the clouds of Venus.